Hi. I'm just going to go over a few quizzes. It'll save some time for the review session tonight. Not really review session, just like want you guys to ask some questions while you can. Okay. So let's see. Hopefully, you guys can see this. All right. So this is the quiz that I actually released earlier. So let's just go ahead and jump right in. So right here, it tells us, okay, acetone by itself has a vapor pressure of 175 millimeters per mercury. What is the mass of the acid, or what mass of the acid, or basically solute, dissolved in 205 grams of acetone, so that's your solvent, to decrease the vapor pressure of acetone to 160. So let's just reuse our equation, right? So this equation right here, pressure of the solution equals the solvent, or the mole fraction of the solvent times the pressure of the solvent. And remember what I said, the vapor pressure of a pure solution is always greater than that of a solution. Or vapor pressure of a pure solvent is always greater than that of a solution. So this X is always a fraction, and you're taking a fraction of that higher, greater pressure in order to get this solution. Right, well, let's just go and plug it into our equation, right? So our solution is 160. Okay, 160 times, probably shouldn't use X, times 175. Our X ends up being 0.914. And if 0.914 is our fraction, our mole fraction of the solvent, that means, remember, by definition, our mole fraction of our solvent, so A is our solvent, we have moles of solvent over total moles, right? And we know that our solvent is acetone right here. Let's go ahead and convert that. It'll make things a lot easier. So we have 205 grams of acetone. And from our molar mass, that gives us 58 grams in 1 mole. So we have 3.53 moles of solvent. So our moles of solvent is 3.53. Their total mole must be 3.53 plus whatever our solute is. Right? Now, if this, by definition, is our mole fraction of the solvent, that must equal our 0.914 we saw before. And now it's just a matter of algebra. You multiply this entire thing by the denominator, you bring that over, and then you basically algebraically you solve for the moles of the solute. And if you do that, your moles of the solute will come out to be so it's basically moles of solute will be 0.332. So basically, remember, multiply this as 3.53 plus moles of solute. Or what you can do is you can just divide this over, and then you can just subtract 3.53 from the quotient of these two. Right. 0.332, that's our moles of solute. We can change our moles of solute to moles, or to grams, my bad. And we know that our molar mass of our acid is 284. Then our grams of solute must be 94.5 grams. Now, question 3, what mass of glucose must be dissolved in 415 grams of water? So first of all, water is pretty much always going to be your solvent. So you know that this must be converted to milligrams because you're going to use like molality. Kilograms. Okay. Here's the mass of glucose. So we solve to raise the boiling point to 101.8. So, well, right here, it gives it to you too, but we all know that the boiling point of water is 100 degrees Celsius, right? And if that's the solution, just find the difference. So, whoops. Minus 100 equals 1.8 degrees Celsius. Now, our delta T equals I times M times K. For delta T is 1.8. And glucose has a Van Hoff factor of 1, insoluble. Our K factor is 0.512, molality. Let's divide that over. We'll divide by 1, that doesn't really do anything, so just leave that out. So 1.8 divided by 0.512, that will equal 3.516 as our molality. Remember, by definition, our molality is going to be the moles of solute over our kilograms of solvent. And we know our kilograms of solvent is 0.415, so we just multiply 0.415 over, whoops. So our moles of solute will thus be 1.459, right? Now, if it's asking us for what mass of glucose, if we have this many moles of solute, which is glucose, 1.459, 1 mole is 180.2 grams. Now eventually get us 262.9 grams. All right. Give me 1 second.